A very good morning to all of you. Myself, Masiuddin Khan. I'm going to explain discrete mathematics in computer engineering because it is always my motto whenever I teach students mathematics, whether it is applied mathematics or discrete mathematics. My main motto is students must understand what are the exact applications or what are the uses of this respective mathematics in your upcoming branch or in your upcoming semester or in your current semester subjects or in a course engineering branch. Discrete mathematics is not any branch of mathematics because we are saying calculus, linear algebra, graph theory, or etc., we always say that is calculus is a branch of mathematics, linear algebra is also a branch of mathematics. But whenever we have to say like discrete mathematics, if I ask a questions what is set, then the answer must be common, a collection of well-defined objects. So when I say what is discrete mathematics, so before we have to define what is discrete mathematics, first we have to know that is what is discrete, because mathematics, all of you are aware what is mathematics, because mathematics is not any tools or any apparatus. Mathematics is completely abstract subject. If you think, then there is mathematics, else it is only a free space. So for understanding of mathematics, you must create a tool in your mind so that that tool will help you the entire semester as well as the entire 4 year of your engineering. Now discrete. What is discrete? Right now I'm teaching computer branch of second year or second year engineering, A and B division both, or both A and B divisions. According to my opinion, I'm just going to give a basic example of discrete mathematics. Right now total 118 or 118 students are joining this class. So I can say that there are 118 students are present in my current lecture or in my class. But if I say or if I ask a question about myself, what are the heights of the students in SE A and B divisions or the current my class, then the answer must be not exactly defined or in a discrete manner. The answer must be a continuous manner, because some students have a height of 5.1 inch, some have 6 feet, somehow little bit 6.5 feet, somehow 4.8, 5.2, etc., etc. Just consider. But when I ask questions, how many students are present in a class, the answer is clear, 118 or 119 or any numbers. So the terms discrete is defined from the first questions, that is exact value, and the second one is a continuous. You will learn a probability distributions or random variables. In that value word discrete and continuous played a very important role. Whenever we have to explain or whenever we have to say what is discrete random variables, I always give an example of basic things. What basic things? There are 4 months of a rainy season in our country. That 4 month we can consider as a discrete. But how much rains will be in 4 months? It is not clearly defined. That process is continuous process. So such a things are known as a continuous random variables. So this is just a basic examples of a continuous as well as discrete. Today we have to learn applications of discrete mathematics in computer engineering. So hope all of you aware about that is what is discrete, not mathematics. Now I'm coming to mathematics. Or before I have to come to mathematics, I want to explain few things Why discrete mathematics is necessary for computer engineering? Why discrete mathematics is not necessary for civil engineering students or mechanical engineering students? Because I'm just giving a basic example of day-to-day life, not going to explain a fully technical, because I'm not a technical person, or I'm not a perfect person who explain your core subject. Maybe your other faculties members or professors will explain very well about the exact and very well applications of discrete mathematics in your respective branch. Now, why discrete is necessary, or discrete mathematics is necessary for computer engineering? You people are learn software engineering as well as hardware engineering. When I'm going to put a key, or when I'm going to press a key A, B, C, D, or any key, when I put, the computer is not going to understand your language. The computer is going to understand only a binary language, either 1 or 0. So 1 means it is high and 0 means it is low. So it is clearly things that is either, yeah, true or false. So your computer will always understand a binary language only. A binary language. So whenever you have to learn encoding and decoding concepts, you must have to understand what is discrete mathematics. You will learn encoding as well as decoding in your discrete mathematics syllabus. So that time you will realize this is really exact applications belongs to your field or your branch. Second thing, you have to learn about hardware engineering as well, like software. So hardware engineering, when you have to learn, you have to know the exact parts of your computer or of your CPU. The all circuits or motherboards which are made up of on the basis of logic gates or gates. Such a logic gates, if you have to design, or if you have to design such a kind of circuit, you must understand what are the exactly logic gates or Boolean algebra. You have a separate chapter of logic gates, so you must have to understand that chapters. So that's why discrete mathematics is important for computer engineering. Even in IT engineering, also a few chapters belongs, because they also have a software part. Now moving forward to our next slide or next topic, a small introduction. Now going to forward, these are the textbooks which belongs to discrete mathematics. The first one is Kenneth H. Rosen, Discrete Mathematics and Its Applications. This is a very useful book. I will share in a Google Classroom a few textbooks which are free in PDF format, so that you can learn and understand the exact applications as well as the concept of discrete mathematics and its applications. Second book is Shom's Outline Series Discrete Mathematics books. If you want to be a good problem solver, then Shom's Outline Series of Discrete Mathematics is very useful, because this book contains all kind of problem set. So if you are a master of Shom's Outline Series Discrete Mathematics books, definitely you can score full marks in your upcoming examinations. Third one is a combinatorial approach to matrix theory and its applications. That book is not discrete mathematics books. This book is based on graph theory, because discrete mathematics is also contains a graph theory. If you want to be a learner of a graph theory, the third book is very important for a graph theory. And the last one is for the students of Mumbai University, G.V. Kumbhojkar. The Discrete Mathematics book is very familiar book because from semester 1 to semester 4 the Kumbhojkar is a famous regarding mathematics. So these are the 4 textbooks you can refer, and such a books are available in our library. Now moving forward, now already I defined discrete mathematics. Now I earlier I just explained about what is discrete mathematics. I explained about discrete. Just there are 4 images. If I'm saying that is a integers and rational numbers, both are the different things, so it is a discrete, separated from each other. Or discrete mathematics is not a name of a branch of mathematics like number theory, calculus. Rather, it's a description, it's a set of branches. It is clearly maths that all have the common features that they are discrete rather than continuous. Or it is a separated things like car and house. These are the not similar things, these are the separated things. So they are the discrete from each other. Now I'm just going to explain what is discrete mathematics, why it is not a branch of mathematics. Already earlier I told about that is set is a collection of well-defined objects. So in a discrete mathematics, as earlier I told, that is it is a separated or it is a discrete. It is not repeated, it is a discrete. So a maths which belongs to or a topic or a branch of mathematics which belongs to discrete mathematics, they are separated or they are taken in a one set. So like set theory, logic gates, graph theory, group theory, some algebraic structures, recurrence relations, these all topics, even probability, all topics comes together and form a discrete mathematics. So when I say a discrete mathematics is a set of such topics. It is a mathematics, but it is a set of set theory, set relations functions, logic gates or mathematical logic, Boolean algebra, group theory, graph theory, poset and lattices, probability like permutations and combinations. Now we'll move forward. Information theory. This is, I just created a simple circular, we can say that simple circular structure so you can understand, or better you have to understand. I just want to explain a few things, like all of you aware about Mission Impossible movies, that is Tom Cruise series. In Tom Cruise series, the most important part is always observe, if you aware about, they always break rules or break any chain or break any lock, because the Mission Impossible, the word is clearly mentioned, that is those things are not possible, they always try and break. Sometimes they break some pen drive's code or some laptop, some account they hack. Sometimes they hack the all security systems, etc., etc. So discrete mathematics plays a very important role in coding as well as decoding, as earlier I told. Now we're moving forward. In engineering branches or computer engineering branches, these are the few specializations. If you learn computer algorithms, programming languages, cryptography, automated theorem proving, software development, in real world problems, discrete maths finds its use in operational research. You will learn in upcoming semesters, so you will understand very well about discrete mathematics applications, or I think the subject belongs to SEM 7 or SEM 8, might be. because you are the luckiest batch. Every year you will get a new syllabus. Once you enter the first year, the syllabus is changed and quite simple. Once you enter the second year right now, again the syllabus change. So might be the syllabus change, but you get this subject in optional, or we can say the elective subjects. Now moving ahead, or I'm just going one example. Few days ago I got a call from Australia, and I had words with one of my students. His name is Discrete. He was our past student, just last year passed. Right now he is doing masters from Australia, that is Sydney. He called me, sir, again I have discrete mathematics. What should I do? Because again it is a very difficult. So can you teach me or can you guide me? I told him that is why not. We set up because Australia Indian timing is really different. So started teaching again from the application based. That time he told that is, sir, without applications, yeah, once we entered, because he was a static second year student, he told me, sir, जब हम second year में entry किए थे तब आप applications basis से ही बता रहे थे. Now I was here, and again it is a totally application based. So my always motive is you must understand the applications of any mathematics, whether it is applied mathematics 1, 2, 3, 4, or discrete mathematics. You must understand the applications, or why should I learn this subject. So that's why you must know about these things. Now moving ahead to next slide. Microprocessor. I'm not a master of microprocessor, but I just learned these things, and I found these things. Earlier the microprocessor were not able to perform floating point. So once after the using of discrete mathematics, they got the floating points. Or better, I give an example of fast Fourier transform. What is fast Fourier transform? Whenever we have to convert a periodic functions from time domain functions to frequency domain functions, you must require fast Fourier transform. Maybe you will understand in applied mathematics, because you have a separate module called as a Fourier series. So you will understand. Even discrete maths provided a faster and more efficient solutions to perform desirable approximations to the real equivalence. Or what suppose I have to say, if I want to check whether this is right or wrong, or true or false, then discrete mathematics or logical statements create a clearly things. Because all of you are aware about right now, you are in second year. What is the use of that logic gates? Logic gates clearly provide the output. If you will get the output, means you are getting the informations. Because if you are getting informations, and if you are not providing informations, means if input is not proper, then by default the output will be not up to mark. So it is basically on that is a clearly statement based. If it is true, then if it is true. If it is false, then might be, because the first one if false, then it will be a difficult, so you will get again a true things. So you must understand this concept properly. In or and of these that things are different, but the main concept is I'm just explaining basic things. If the starting point of the connections in a circuit is loose, how can you get the output? This is just basic example I'm giving. The microprocessor is based subject which is based on your circuiting system or circuit creating system. The next thing is software development. Again, as earlier I told about what is the applications of discrete mathematics. As earlier I told that is your computer understand only only language is binary language and 0 and 1 bits. It is only binary language. These two are the discrete numbers, not following continuous maths. because it is 0 and 1. It is not a continuous. This is a discrete, is separated, or it is a discrete, not repeated. So just try to understand this thing. It is traffic light and compiler implementations. In traffic light programming on a 6-way intersection, map coloring algorithms are helpful. You have to learn, I think, map coloring algorithms in your recurrence relations. Even in optimization or optimizing compilers, you have to use uh, discrete mathematics. Today I'm not going to explain clearly about the subjects or syllabus things. Today my first lecture is only introduction about discrete mathematics and computer science, so you must understand. So lattices is there. You learn lattices. During lattices, definitely you will enjoy and you will understand very well. This is next slide. Automatic integrities checks. This is just I take an example. There is a company that provides road data for ABC systems. They wanted automatic integrity checks on their data. One of which was that the network should be or all be connected up. It should be possible to get to anywhere from any starting point. This statement is important. Checking the data by trying to find routes between all pairs of positions would be impractical. However, it is possible to derive a directed graph from the road network data in such a way as it encodes stuff like turning restrictions, such that the problem reduced to finding the strongly connected components of the graph, a standard graph theoretic concept which is solved by an efficient algorithms. So again you have to learn a graph theory chapter, in that you always learn algorithm concept, so that whenever you have to define any network system, you must understand the graphical system, because if you aware about that is the all the network systems, that is topology, then it is totally based on mesh topology or something, a different kind of ring topology is there. So you must understand what is topology, because the network system, you are using a Wi-Fi, you are using a mobile network system, the mobile system, the all things are based on the network based. So for understanding of network things, you must understand the concept of graph theory as well as tree is also chapter belongs to your syllabus. Now, theoretical computer engineering. Theoretical computer engineering includes areas of discrete mathematics relevant to computing. Theoretical computer engineering also includes the study of various continuous computational topics. Theoretical computer engineering includes area of discrete mathematics regarding computing. There is a computing technique. In computing technique, you must understand what are the why should we have to do computing. So if you understand the recurrence relations and all the stuffs, definitely you will clearly, your vision must be clear about the computing. Now I started the chapters. Mathematical logics. As earlier I told, what is mathematical logic? Logic is a study of principle of valid reasoning. Without reasoning you are not possible, or you are not get any space for clearing of any numericals or any digital circuit. Because why I'm saying digital circuit, because right now we are using a digital things. Well, computer is based on digital. There is analog as well as digital. I'm just giving you again a big example of discrete and continuous. Discrete is digital and analog is continuous. Why? Because if you see a watch which is continuously, if you just observe a second hand, then you will see it is a continuously moving of watch. But if you see the digital watch, it is totally based on continuity, 56 seconds, then 57, then 58. But the analog is based on continuity. So that's why I again told tell you that is these are the separated things. So try to understand these things. The study of mathematical proofs is a particular important in logic and has applications to automated theorem proving and formal verification of software. Now we'll move on next slide. Sets, relations and functions. Now set theory is a branch of mathematics that studies sets which are collection of objects. Now the partially ordered sets and sets with the other relations have applications in several areas, or basically when I have to say anything for a development of database. Without database you are not able to perform anything, because right now I'm saying that is in the first year we got admission of 171 students, and that students are maximum belongs to computer branch, and the second one is IT branch. Few belongs to civil branch, few belongs to EXTC branch. Right now when the second year engineering started, I saw the live example of the database development is I got data of maximum computer engineering. So computers, both the divisions are started. We got one division students for IT, and the IT is fully started. But if I saw that is civil branch is having 120 intake, but suddenly they got few very small admissions, so very small number of admissions, so that they have a less database. But if you don't have a students, and how can we teach? So this is the just example of without database development it is a very hard to survive, or it is very hard to take any actions. Like if you see that is a database development, whenever you have to perform any practical or any things, you must have to take a trials. Once you will get a maximum number of trials, according to that database you are going to define, it is clear. Now we have to go move on the next slide. Now the next one is theory. As earlier I told, graph theory, the study of graphs and networks, is often considered part of combinatory. Always I told in starting that you have to must read that textbook. You will really very good, very understanding book, and you will get a very good knowledge for graph theory. They can represent networks of the communications, data recognitions, computational devices, the flow of computational etc. They are also continuous graph, like this is node. I just given one example. Discrete probability theory. Discrete probability theory deals with events that occur in a countable sample spaces. Discrete probability distributions can be used to approximate continuous ones and vice versa. For highly constrained situations like dice, or calculating the probability of events is basically enumerative. So what is probability basically? For probability I always give a basic example. Every morning we have to set alarm for 5 a.m., 6 a.m., 7 a.m. or 8 a.m. anytime your uh, your feasibility point. So suppose at 5 a.m. if any students set alarm during the college days, alarm is ringing, the students wake up, and if he thought today my thinking is not to go for college, just we have to relax at home, so his probability is different, and his one of friend is also set the alarm at 5 a.m. He wake up and he thought nahi aaj se jana hai college. So these are the two different probability. Just start from early morning. Now probability is clearly mentioning is from day start, you started with the probability, because after waking up you start taking a shower, and just you have to start your matching with your jeans and t-shirts. So this is also part of probability. But in a day-to-day life, we never observe that is we are using probability. So for day-to-day life to technical field, the probability is very important aspects or very important conceptual subject for technical field. Theory. Number theory is belongs to rational algebra basically for the database, discrete and finite version in algebraic coding theory. Trees, as earlier I told about, trees are used to represent data that has some hierarchical, or hierarchical means what? If you are set any network system, then might be the one PC or one laptop is your server. So according to that, the rest are the different places, and from that, or I'm just taking any uh, we can say that any company examples. Like if you are working at TCS, then who is the CEO of TCS, who is the general manager, who is the director, who is the team leader of your respective branch, and then you are a member, or you are a team leader, or you are a team's member, whatever. So this clearly mentioned that is CEO, director, manager, heads, etc., etc. In our college we have that is a CEO, director, then campus director, principal, head of departments, faculty. So these are the completely tree or hierarchical relationship amongst the data of elements. So this is just a basic example I'm just explaining. In a technical things, it is again clearly mentioned that is if such circuit is not completed, then the next circuit will be not going to start. So these are the things which are based on trees. So you must understand what is tree. In conclusion, we emphasize the essential role that mathematics plays in the development of computer science, both for the particular knowledge and for the reasoning skill associated with mathematical maturity. I'm always said that mathematics is completely abstract subject, whether you are going to learn discrete mathematics or any applied mathematics or pure mathematics. This subject is totally abstract. You must create a one tool for understanding of mathematics. If your mind is created any tool of mathematics in your mind, definitely you will be a good learner in mathematics. Lecture onwards, we are going to start the actual syllabus or the exact syllabus of our first chapter, set relations and functions. But the chapters are divided. The first one is a set theory. So I'm going to start the set theory from the next lectures. But this online teaching learning method is divided into two professors. Myself is Masiuddin Khan, and the second professor is Professor Nitish Chaubey. So we are going to teach the two different chapters simultaneously. I'm going to start to set theory most probably, or maybe sir will start logic gates or any other subjects. He will clarify which chapters he is going to take or he is going to start. Now thank you all. See you later. See you in upcoming lectures. Thank you. Thank you so much.